So you've installed your new generator and you're going to power it up, but there always seems to be one thing that a lot of people wonder, I think, is what's the load current on my generator? So if you've got a generator that supplies 10 kilowatts, you have really no idea to know what the load is, how close you're getting to the rated capacity of the generator. And what I wanted to do in this short video is just give you some ideas about current monitoring, specifically the use of current transformers. I'm not going to get into the theory of current transformers. You can find plenty of that stuff on the web. But what I do want to do is talk about the different kinds of current transformers. And I think one of the simplest ones for home generator current load monitoring is just a donut CT or current transformer connected directly to a meter. The cool thing about that is there's no additional circuitry. You don't have to use an Arduino, or you don't have to use a microcontroller to scale the voltage, or it's just, yeah, it gets more complicated. You have to have a separate power supply. So let me get started. So this is a generator metering box that I'm building. I've got a 30 amp connection for a generator in the barn, and I just decided, hey, I'm going to do a 50 amp. So anyway, this box, its job is to monitor the load current on my generator, and it's a 240 single phase. But what I'm doing here is I'm monitoring each leg of the 240 volt power line coming in or from the generator. So I've got 120 on each side, or whatever it is, 125, it's to 250. I think mine's 250. So anyway, but what I'm using specifically is a current transformer for this meter. And just a quick commentary. This box is, I thought I'd build my own box. I'm not going to buy one off of Amazon. So this generator input plug is for a 50 amp service. It's made by Hubbell. It's not a Chinese company. It's an American company. And I tell you, when you're drawing 50 amps, I'm not going to do it through something. I have no idea what the build quality is. So, but let's talk about the specific current transformers that we get into. So this is a donut, what's called a donut CT. And it's kind of like a clamp-on ammeter, except it's not split. You've got to pass the current carrying conductor through this. You'll notice something interesting. This is a 100:5 ratio, and this ratio is important. Here's another example of another current transformer. And this one is a 50, if you can see that. This one's a 50:5 ratio. What that means is that 50 amps of current, the output of this CT is going to deliver 5 amps. So it's ratioed 50 amps to 5 amps, okay? So that's important. On this 100:5, this one ratios at 100 amps. This transformer output will be 5 amps. So now the other thing, not to get too far off the path here, but you've got a lot of other different kind of current transformers, and you can see I've got a little collection here. Let's just look at this split core transformer. These are some other transformers you'll see. Let me see if I can split this open. There we go. Okay, so the nice thing about these is you can put these around your current carrying conductor if it's already installed, and that's fine. But since you're probably doing a new install, you're going to want to get just the solid ones. And the other thing is that you'll notice, this is what I was talking about earlier, this will do 250 amps, but that's 0 to 5 volts DC. So what happens is this is looking, when you've got a 250 amp load on the current carrying conductor going through this hole, it's going to produce 5 volts. So it scales from either 0 to 5 volts or 1 to 5 volts, but then you need a digital analog converter to convert that voltage into something that's readable, say on an LCD screen, whatever. But then you start getting complicated, because now you've got a microcontroller to scale, you've got an A to D converter, you got to supply that power. And here's an example of a digital panel meter that's actually made for that. This one's AC amps, and you'll notice on this one, This one has a full scale, see the FS 0 to 5 amps, and the scale is 0 to 100. So what this digital panel meter is doing is it's saying, hey, when I at 5 amps, when I see 5 amps coming in to my input back here on the screw terminals, I'm gonna show 100. Okay, so we see a 100 on the amps on the LED display here. But again, you've got to have a power supply for this. They're long. They don't necessarily mount well in boxes unless you've got some big control panel. But I just wanted something for reliability that I wasn't going to have to mess with, so I'm going the analog route. But I'll also show you on one of these meters, same thing. On the meter, you're going to see, if you can read that, the rating is 0 to 5 amps. The scale is 0 to 50 amps. And what that says is at 50 amps, this meter will read that this meter wants to see no more than 5 amps, but it's scaled to 50 amps. Okay, so really, this is just divided by 10, but you have to use a current transformer because if you shove 50 amps into this meter, you're going to blow it up. So that's, what I wanted to do was kind of convey how these CTs work and the ratios, because you may see a meter that you want to buy that says, hey, I want to measure 50 amps, so you go buy a 50 amp scaled meter, but it may actually be a 50 amp input, and it would have to have an internal shunt or an external shunt, or you've got to have a current transformer. And now the nice thing about these Yokogawa meters is it says current transformer on it. So if we look at this triplet meter, and this one happens to be a 0 to 100, if you'll notice here, if you can see that, use with 100 to 5 amp current transformer. So it's telling you that at 100 on the scale, this meter is reading 5 amps. So we have to get a CT that matches the meter. This meter wants 100 to 5 ratio CT, and this is 100 to 5 ratio CT. This meter wants a 50 to 5 CT, and this is a 50 to 5 CT. But let me give you a word of warning about these CTs. They produce, unloaded, they produce a huge amount of voltage, and it's a dangerous amount of voltage when your circuit is energized. So you always want to make sure, generally you should just keep the lead shorted when you're not using it, or any time that you've got it, even if you should never put current through them while the leads are disconnected. They always need to be connected to a load. So in this case, if we were going to use this 0 to 100 amp meter with this CT, we just connect the black and the red to the back of the meter here. That's it. There's no external power needed. It's very simple to do. And the nice thing in a sort of a grid down situation is you don't want to add complexity to your environmental power system, your power system. So keep it simple. And these CTs are not that bad. I think I got this one for $15. It was used. I got 2 of these 50 to 5 amp CTs for I think about $35, which is pretty cheap. They're new. The nice thing I like about the smaller rating is it's a smaller CT. So when I put it in this box, it's going to take up less space. And I'm just going to quickly flip this, so bear with me. All right, so here's the other side of this box. These are the voltmeters up here, and these are the CTs down here. Now, one thing that's important if you're going to do what I did here is you're going to want to fuse the voltmeters, but never fuse a CT. Just do not do it. You're not supposed to do it. Don't do it. Now, the other thing is, I guess I'm an industrial engineer, electrical engineer, so I always try to go for the good stuff. But these transformer pilot lamps from Allen Bradley were $10 on eBay, brand new. Get good stuff. Don't get cheap Chinese stuff, because you may pay a price for it. So, but like I said, your current monitoring for your home generator, and you don't have to monitor both legs, you can just monitor. If you just want to know what the big loads are, like your air conditioner, like your dryer, like your whatever any big load you've got, just monitor one leg. Just monitor, because that's going to be the total current through the 240 volt total supply. So if you just want to monitor one leg, I was kind of interested in monitoring both legs because I want to pick up some of the 120 volt loads that are going to show up on each side of each L1 and L2. So if you just want to monitor just the big loads that take 240 volts, just get yourself a meter that's appropriately or just that uses a CT, simple, and then just get a CT that's ratioed for the amount of current you want to measure. In this case, I have a 50 amp generator, and I don't want to mess with a 0 to 100 amp because it's harder to see the needle deflection. So I wanted to get a one where I could get a better, more accurate indication of what is the load current as I turn on an air conditioner or as I turn on a well pump, anything like that. So anyway, I hope that this has been beneficial. This is, I think, a topic that doesn't get covered very much, if at all. I'm sure a lot of people would like to measure their generator load current to find out, how close am I, or can I add this additional load, or am I going to trip the generator? So anyway, real simple. So I hope this provides value to somebody just for some ideas. Thanks.